In this one, I'm going to teach you to become a lord of time in Python. Python has two different libraries for dealing with time. It has time and datetime. The time library is a little more lightweight than the datetime library, and as of Python 3.9, it really hasn't been necessary to use datetime because the limitations of time seem to have been removed in that patch. So the first thing we need to do is import time. This is part of the standard library, so we don't need to pip install it or anything like that. Once we've imported time, we can do something like this. Print time.time. This is a function, so we need to put brackets and run it. And you'll see we get a really long number. Now, what the hell is that? Well, the time library deals with the time in seconds since epoch. And epoch in Python is the 1st of January 1970. So that is the number of seconds that have elapsed between then and now. It's quite a large number. And if we want to see what the time is, we can do print time.ctime. And you'll see we get Sunday, August 18th at 6:56:04. We won't use ctime very often because normally we just want to format the time the way we want it, not the way it generates it. Now, it's also important to note that we can do time.ctime on any time. So if we put in 0 seconds there, that will tell you that we're in January the 1st in 1970. So that is epoch at 0 seconds. Now, we can add days to time quite easily. And the way we do that is some simple maths. So I'm going to declare some variables. So I'm going to create minute and make that equal to 60. Then we'll create hour, and that will be 60 times minute. And then we'll make day, which is 24 times hour. And if we print day, that is the number of seconds in a day, which is 86,400. So if we do 0 plus day, we will get the 2nd of January. Let's put 365 days, should take us around about, no, times day. Should take us around, yes, the start of the next year, 1971. So that's the basis of time and how we manipulate it. Now let's look at some ways that we can write time ourselves for use in our program. So I'm going to remove ctime now, and we're going to start working with today's date. And what we're going to do is we are going to print time.localTime, and we are going to pass in the time. And actually, let's capture that time in a variable. So cur time :equals. This syntax is pretty new in Python. It allows you to run something within a bracket and actually record it to a variable as well, rather than do two separate lines of code. And then we can pass in cur time here. And you'll see what that's done is it's actually generated a time structure, or a struct time. And if we look at this, you now have TM year 2024, month 8, day 18, and hour 19, and so on. And we can see that I'm in daylight saving in my local time zone. Now, using struct time, so if we create t :equals, so this will print the time and record it to variable t, and then I'm just going to do print t.tm year. MT, not TM. And there we go, 2024. So we can actually pull things out of the date and manipulate it as we see fit. Now, this is all very well and good, but we want to actually print this in a more human-readable format. And the way we can do that is if I do time.string ftime, which stands for string format time, and then we pass in our time variable t, and you always need to use a struct time with this. And then we are going to add our formatter. Actually, no, that's our time. This is our formatter. So our time is t, and our format is going to be %d dash %a dash %Y. And if we run that, we get 18th. Okay, A is the wrong one. So there is a reference for time we can look at. And if we pull it in here and scroll down, these are all of the special variables we can use to declare time. And what I want is the month name abbreviated, so it's actually B, not A. Okay, so now on the 18th of August, and we can put in the day, and to put in the day, we just need to find day of the month as a decimal number. Don't want that one. Well, I think A was the one, wasn't it? Local abbreviated weekday name. Full weekday name is %capital A. Put a space, and now we should get Sunday. And if I put in a dash there and run it again, you'll see we can start building this up. And then let's fill out the hours, minutes, and seconds. And I think these are all capital in time, if I'm not mistaken. And then I'm going to do %capital T, and I'm going to put that in brackets. and run that, we got an invalid syntax. So something is wrong with what we did. Oh, that's because it's outside the quotes. Okay, and now we got Sunday, the 18th of August at 7:04. Now that's interesting. Why did that do that? Oh no, it said. There we go. So you can see GMT daylight saving, which is my time zone. Now what we can do, instead of using local time, we can use GM time. And this puts time in coordinated universal time. So you got GMT standard time, and we jump back an hour because I'm no longer in daylight savings. I do suggest that if you're working with Python clients from multiple regions that may be in different time zones, that you always get the time in standard time and then convert it later. This is especially important if you're going to store that in some kind of database file or an actual database, because you want to make sure that whenever you show the time to a client that a transaction occurred, that it's done in the time of their local time. But you can't really do that when you're mixing all kinds of different time zones together. It gets really difficult. Once it's in GMT, we can convert that back. And the way we can do that is just to store the time.time value, because that will be in UTC by default. And then we just cast that using string format time or whatever we want to get it back to where we need to be. Now, as well as converting a number of seconds to time tuple, we can take a date and convert that back to a time tuple. So how do we do that? Well, let's create a variable called pt, and I am going to do time.string, but ptime this time, which stands for parse. And I think this is the one that's the other way round. So if we create a date, and we are going to copy in this formatter here because we're reversing that format. And then if we print ttime, we should get a structure which shows that date. So we now got a time tuple. What if we want to get that back into seconds? Well, the reverse of doing time.localTime is actually something called time.mkTime. Don't actually know what this stands for, but we can pass in a TT, and let's just print that. And we should now be somewhere near our number of seconds. And we are. Now, you may have seen me use time.time before when I'm timing programs. So what I would tend to do is something like start equals time.time, end equals time.time, and then we can print end minus start, which will give us the total number of seconds that have elapsed between start and end. So if we run that, we'll get something along the lines of 0. Now, another thing you can do with time is tell the system to pause. And the way we do that is time.sleep. And if I say time.sleep 2, you'll see that it takes 2 seconds before it prints the end time, or around about that. It's slightly inaccurate. But this is really, really useful if we're taking messages off a queue, but we want a sleep time, so we're not just constantly pounding the queue, because there may not be anything in it. Then sleeping temporarily doesn't use our CPU, it just tells the process to pause. And we'd use something much smaller like 0.25 in that case. So it would be something like get a message, wait 1/4 of a second and try again. You can also use this for trying to get a lock, all kinds of scenarios you may want to sleep. And you can see there, 0.25. So if we do for underscore in range 4, so this should loop 4 times. We're going to time.sleep, and then we'll get the output time. And we're back up to a second. So sleep is really, really useful. Now, if you happen to know various things about the date, there's one more thing I want to show you. And that's kind of like using this make time, but instead of passing in a time tuple, we can do print. And I'm actually just going to get rid of this timer because we don't need it anymore. Time.mkTime. And this time we're going to pass in the variables. So 2024, the month is August, and we are on the 18th day. And then I'm going to ignore everything else. And there should be 9 values in this tuple. 4, 5, 6, 7, 8, 9. And then the last one I'm going to set to -1. It doesn't like leading zeros. Let's try that again. Okay, so we've now got this time interval, which is the beginning of today. What I'm saying with -1 is that I don't know whether this is daylight savings or not. And the system will calculate that for us if we put in -1 for the daylight saving time. Now, at the beginning of the video, I mentioned that you could use time.time for pretty much everything now because a lot of the limitations have been removed. What I was specifically talking about there was dealing with negative timestamps. This was working fine as of Python 3.9, and it looks like it's broken in 3.12 again. When you try and use negative timestamp in any of the functions, you get argument out of range or invalid argument. So it does look like if you are going to use negative timestamps, at least for the time being, it's safer to use datetime. I will be making a video in future on how to use negative timestamps using datetime, so you can get around that challenge if you need to. So that's it. You now know all about time in Python. If you found this useful, then please don't hesitate to click the like button. And if you don't want to miss out on what I post next, then subscribe to the channel. And with that, thanks for watching, and I hope to catch you on the next one.